Steam locomotives in miniature at the Steam Workshop Part 16, fitting the running boards and the mechanical lubricator. I'm working on a 5-inch gauge Chubb locomotive, and it's been quite a journey from pulling it apart, having it painted and putting it all back together again. What I'm doing at the moment is fitting the outlet pipe from the axle pump, which will feed the water from the locomotive's side tanks into the boiler. I'm making doubly sure that this gets fitted correctly the first time, because once the boiler's in place it's very difficult to get to. So I'm using a little bit of Loctite 542 on the union and on the threads. You will notice on this pipe, between the pipe and the union that goes to the clack on the boiler is another pipe sticking up. This goes to a bypass valve which allows the water to go back into the water tank rather than feeding the boiler. The theory of operation is simplicity itself. When the locomotive is running along the track, the axle-driven pump is working all the time, and this is no good because you don't want water constantly going into the boiler. So by adjusting the bypass valve, you can allow some back to the tank and some to feed the boiler. When you get the position of the bypass valve just right, you can feed a very small amount of water to the boiler all the time when the engine is running. This is the oil feed pipe from the mechanical lubricator to the cylinder, and in this clip I'm tightening up the union nut using a small spanner. Regular viewers to the channel will notice that I'm not using my Barco spanner for this job, it's just a little bit too big to get in this confined space. Instead I'm using a standard but very small open-ended spanner. Once the union nut is fully tightened, I can move on to the next part of the operation. Now I have to fit the running board first before I can tighten down the lubricator onto this one-way check valve fitted onto the end of the pipe. This, by the way, is the difficult part, actually fitting the running board. As you can see from this clip, I had to remove part of the valve gear, and then, trying to avoid marking the paint, I very carefully eased the running board into position, and it was quite a tight fit all the way around. It's inevitable when doing a job like this that the paint is going to get slightly damaged, particularly on the edges. But the good thing is this really high quality paint that Steam Workshop use is really good, and you can touch it in with a brush, and once it dries thoroughly it matches the original paint. In this clip I'm showing how I'm using some Loctite 542 on the thread of the check valve into the bottom of the lubricator. This will prevent any leakage when the pump is working, because when the locomotive is running, the oil pump will be pumping oil into the cylinder at pressures up to 80 pounds per square inch. In this part of the clip I'm refitting the driving bolt because I removed it just in case it scratched the paintwork. And here's the lubricator in the correct position, and it's also now piped to the steam chest. There now follows a top tip to make the job easier. Generally speaking, sockets in socket sets, and even ones like this, are not ideal for fitting very small hexagon bolts, because the hexagon hole in the socket is usually too deep. So what I do is push a piece of tissue paper in there, so when I position the bolt in the end of the socket, it doesn't go all the way down. As you can see here, it's just the right length. So now I can fit the bolt into the hole, and the compressed tissue paper in the actual socket puts positive pressure on the bolt and makes it much easier to fit. Without the tissue paper, the bolt would just retract up inside the socket. There's another reason for using tissue paper before anybody writes in saying, why don't I use a piece of silicone rubber, why don't I do this, that and the other? Well, I use tissue paper for a couple of reasons. The first one is it's very easy to remove if I no longer need it in there. And the other reason for using the tissue paper is that I can use some steam oil like this. A very small amount applied to the tissue paper in the end of the socket will hold nuts and bolts in place, allowing you to use the socket in an anti-gravity situation. For instance, when you turn the socket upside down to fit the bolt or nut. You've just seen me pour a small amount of steam oil into the lubricator. This is just to lubricate the central column and the moving parts. You will notice I haven't filled up the lubricator properly, because very shortly the locomotive will have to be positioned vertically to allow me to fit the pipe to the underside of the boiler feed pump. This is the lubricator drive, and it's driven from the centre of the expansion link. I threaded the brass arm 6BA, and this is a 6BA bolt. Then I fitted a lock nut very tightly against the arm itself, which will then lock the bolt to the expansion link pivot shaft, which has a hole threaded 6BA down the centre of it. These nuts need to be really tight. Not too tight as to shear off the bolt, because bear in mind it's only 6BA, but they do need to be tight. If this arm works loose, the cylinders will receive no lubrication, and that will be a bad thing. This is a small bolt that secures the driving arm at the lubricator end. The entire lever arm on the lubricator needs a small amount of attention, it's only adjustment. With the lubricator fitted in place and the driving arm fitted in place, when I ran the locomotive up and down the bench, the lubricator didn't work properly. But once I adjusted the arm and the ratchet pawls, it now works perfectly. So that's the difficult side done, now for the easy side. This is a mirror image of the first part of the video, so I'm going to speed up quite a lot of it. The first thing to do was to remove the pin from the lifting link of the valve gear. I thought that fitting the running board to this side of the engine was going to be simple, but I should know better by now. It really wasn't simple at all. It did not want to go into the right position. It's a very tight fit. And after many attempts, I decided the only way to do it was to press it down underneath the lifting arm, which unfortunately would mark the paint. But this is not a major issue because the paint mark is underneath the tank, and in any case it's going to be very easy to touch in this paint once the running board is successfully fitted. This part of the job took quite a while to do, and the golden rule is never force anything because it will probably break. On this side I needed to use some nuts from underneath, and once again the piece of tissue paper that I fitted into the end of the socket proved to be very useful. Some of the holes in the chassis had become blocked with paint. These are only 8BA bolts, which are very small, very fine. So what I did was I used a tap to clear them. But I got a problem, the tap wrench wouldn't fit near the smoke box, so once again, to the rescue, my wonderful Barco spanner. And while on the subject of spanners, look at this. I've never seen one of these before. What an incredible, innovative tool. I really want one of these. This belongs to the Steam Workshop, so that's where it will stay. A full set of these, covering multi-sizes of small bolts, would be really, really useful. But for the moment, it's back to my socket set. These are 4BA bolts, so they're a good bit bigger, and they used to hold the footsteps in place. Originally this engine only had one set of footsteps, but thankfully another member of the Steam Workshop team made an identical set for the other side. Obviously I can't leave the heads of these bolts exposed to the elements, they're just going to go rusty, so it's time to very carefully paint the top and sides of every one of these hexagon bolts, as well as touching up any of the marks that I've made by assembling the parts. And I must say that this job requires a good deal of patience. And now it's playtime. No, it's a steam test that's taking place just outside the Steam Workshop in the yard. This is a 4.5-inch scale Burrell agricultural traction engine, and here it is just ticking over outside the Steam Workshop. This is not such a miniature traction engine. If you look at the size of the man, you can see how big it is. When miniature steam locomotives, whether they be road or rail, get to a certain size, they start to smell very much like the full size. The strange thing is, very small live steam engines that are coal-fired smell very differently to the larger models. I think it's something to do with the volume of coal tar coming out of the chimney mixed with the water vapour, which we all call steam. Steam, by the way, is not generally white, it's an invisible gas, and superheated steam is incredibly nasty, but it's really good for running traction engines and steam locomotives. Here you get an idea of the size of it because it's going for a run down the yard. And that's it for this episode. Thanks for watching, and I hope you found it useful.